Kia ora guys, today I'm going to go through this practice question, and that's the question about, so Eden Park is a large stadium in central Auckland, so you probably recognise it. What I think this practice assessment is good for is practicing your achieved and merit skills. I can't really see any ways to show any excellent skills during this. So first things first, generally you've got to read the context. But what I noticed when I was reading through this context, blah 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 blah. This is all useless, redundant knowledge. So we can actually just skip that out. It may help when we're answering in context, but for now we don't need to worry about it. Also, this picture here is exactly the same as this picture over here, just with less detail. So we're actually just going to purely focus on this picture here. So calculate the area. So that's really important. The fact that we're looking for area is critical. Of the piece of land marked out in the diagram, the coordinates are distances in meters from a survey mark located at the origin. So this here is actually kind of hard to understand at face value, but pretty much all it's saying is these are coordinates. And also it's quite important to notice that it's in meters. So when we answer these questions, we're going to have to make sure that we answer with units and make sure those units are either meters or meters squared. So we've got our four vertices here. They're kind of hard to read on the worksheet. And I'm just going to have a little think about this before I attack it. So we've got this shape here. And if I'm having a look at this shape and I'm comparing it to any of these shapes down here, it doesn't look like a rectangle. It doesn't look like a parallelogram. It doesn't look like a triangle. Ooh, actually, we could split it off into two triangles, maybe, and then we could find out the area of both of those triangles. But it does look a little bit like a trapezoid. So how are we going to check that this is a trapezoid? What are the features of a trapezoid that are of interest? I think something to bear in mind is with a trapezoid, you have a set of parallel lines. So we can test that these lines are parallel, and that's probably a good place to start. And then we can see if we could use maybe this trapezoid formula to work it out. Although if we find out that they are parallel, actually the first thing we're going to do, let's label this here. What point looks like the nicest point to be our A? Let's just choose it like this. We'll just go A, B, C, D, because they don't have labels, so we're just going to label them off. I probably should have done them in the order of this, but oh well. Let's just transfer those coordinates over to here. A, B, C, and D. It's probably good to draw a picture while you're in the internal just to get your head around a problem. If we do find out that these gradients are the same, so if we find out that the gradient from A to B is equal to the gradient from D to C, right? We're still going to have to find, if we look at the formula, we're still going to have to find the height. So we're going to have to find a line that is perpendicular to DC in order to be able to find this distance. So we're going to have to find the distance from A to Z, given that AZ is perpendicular to DC. So notice how I'm sort of coming up with a strategy as to how I'm going to solve this problem. So this here, we could say that the gradient of DC is, when multiplied by the gradient of AZ, is going to get us -1 because they are perpendicular. So this is the information I'm going to need. In fact, to find out where the point Z is, we're also going to have to find the equation of the line DC, right? And we're also going to have to find the equation of the line AZ. And then we're going to have to put these equal to each other to find out where the point Z is. So that's pretty much my strategy for approaching this question. If we're going to use a trapezoid area to solve it. Sorry, teachers keep randomly walking in. So if you hear small noises, don't worry about it too much. The other approach I could have, I just want to briefly have a look at it as well, is I could get my trapezoid, and if I say I find out that these aren't parallel with each other, right? So maybe the gradient from AB doesn't equal the gradient of DC, we're then going to have to split this off into triangles and then solve them. So let's have a look at what that might look like. So maybe I do a cut down here. Oh, it's not very straight. Oh well, we'll live. Right, so we've got A, B, C, D. And we're going to have to deal with the area of triangle ABC. And we're going to have to deal with the area of triangle ACD. And when we're trying to find the area of a triangle, maybe we find out what the distance is here. So we would find out distance AC. And once we've done that, we're going to have to find out a line that is perpendicular to AC that connects with B, right? So then we could find out the height of this triangle ABC. So we're going to have to make a point here. So ABCD, maybe we'll call that E. And we're going to have to do a very similar set of steps to what we did here. And then we're also going to have to find out, I'm just going to pretend that this looks nice. Visually, it might not look exactly how I'm drawing it, by the way, but we're going to also have to find out the height of this triangle here. I'm going to flip it around so you guys can get a better visual understanding of that. So we'll also have to find out the height of this triangle. And I know it's tempting to assume that the height's exactly that, but it's likely that that's not the case. We're probably going to have to find some line that's in here somewhere that's perpendicular. So we're also going to have to find this point, whatever it is. That one's called E. So maybe we will call this one F. How do I draw that so you guys can see it? Point here called F. Right? So those will be the two techniques. But let's just hope that gradient AB is equal to gradient DC. So let's have a go at doing that now then. I'm just going to discard this piece of paper. So then I can show you, I want to fold this up, why not? Because we're going to need these coordinates at hand. It'd be quite helpful to have them there. I'm just going to label them over here. So I labeled them stupidly. A, B is the one that starts with negative 38, C is the one that starts with 134, and then that's the only one left. Right, so remember our strategy, which we probably should keep at hand, was we're trying to find that if the gradient of AB was equal to the gradient of DC. So we're just going to check if this gradient here is equal to that gradient there. So let's do that. So I just do a little m. I make sure it's a lowercase m for gradient, and I do an uppercase M when I'm doing a midpoint. So lowercase m of AB, and we will follow a formula, and the formula for gradient is y2 minus y1 over x2 minus x1. So I'm going to make B my x2, y2, and I'm going to make my A x1, y1. So I'm going to actually draw that in here for the people that are not quite sure. Oh, I think I may have screwed myself over there, to be honest. A equals negative 98, 15. And I'm going to make that my x1, oopsies, y1. And then B is going to be, which is here, negative 38, 165. Oh, I'm sorry about that focusing issue. Maybe I need to turn off autofocus, but I don't think that that's an option. It's totally not an option. Focus there. Yeah, but it only autofocuses. Yeah, you can't have it on set focus on the page. I'll work that out afterward when I make my next video. I'm trying out this hovercam, by the way, people, because I look like too much of a peasant if I keep using my cell phone. Although my cell phone was actually better than this. So there you go. Anyway, so this is going to be my x2, y2. Oh, that focus must be so annoying if you're watching this video. Focus there, you dumb camera. serious? Got one job. Set, focus, go. Meh, that'll do. Okay, so we get y2, which is 165, minus y1, which is 15, over x2, which is negative 38, minus x1, so that's minus negative 98. So honestly, if you're in the internal, don't try to do these in your head, and don't worry too much about negatives and positives being done in your head either. Just do them on the calculator and then you're safe. 165 minus 15. You could do this all in one pop actually. Let's be lazy, eh? Chuck that in brackets. And then over, and then chuck the bottom in brackets. Negative 38 minus, so I use this key for minus, and then this key for negative. So see how it gets minus negative. So minus negative 98. And then click that. So that'll actually give us a fraction, which is cool. And if you don't like fractions, if you're working with decimals, your calculator has this button here called F to D, which just changes the fraction to the decimal, or if you're in a decimal, it'll change the decimal back to a fraction. If you're using a scientific calculator, the button that we have for that is S to D, which is that a surd? Surd to decimal? Maybe. Who knows? So it's got 5/2. I actually like fractions. I tell my class that fractions are your friend, decimals are the devil. So I'm going to stick with 5/2 as my gradient. So that's the gradient from A to B. So now we're going to have a look at the gradient from D to C. So I'm going to chuck it over here. So then we've just got our coordinates here. So that's MD to C. So we're going to go from D to C. This time I'm going to do a little less scaffolding than the one above, so you can just follow that if you want scaffolding. So I'm not going to do the formula, I'm just going to go straight into it. So D's Y value is negative 83.7. C's Y value is 233.8 over D's X value is 7 and C's X value is 134. And if you want to just do a quick check on them, just make sure you're using minuses, sweet, and then make sure these match up with your y2, x2. So, where are we? Yeah, 7, negative 83.7, sweet. 134, 233.8. Yeah, looks good to me. It's always worth double checking because it's easier to do a double check as you go rather than going back, rubbing everything out, and having to do everything all over again. I'm going to do this one on the scientific calculator, if it works, which it does. Scientific calculators are pretty cool because they've got this awesome fraction function. Oh no, I don't have a negative 83 point. I've got no buttons on this, so it's quite hard to work out what I'm actually doing. Negative 83.7 minus, I think that's where the minus is, 233.8, and then I go down to get to the bottom of my fraction, 7 minus 134. And that is 2.5. I don't understand 2.5. I'll click S to D. Aha, that's the fraction, 5/2. Aha, there you go. So now we can see that these numbers are exactly the same. So therefore, we can write, therefore, all right, I'm going to go MAB equals MDC, therefore parallel. Now, if they're parallel, that means that our first assumption was correct, and we can follow these steps to work out the area of a trapezium. If we found out that they weren't the same, we would have to settle for cutting this in two and finding the area of two triangles. Okay, so, but because they are parallel, we now know that ABCD is a trapezoid. In fact, I don't even think New Zealand uses the term trapezoid. I think it's an American thing. I think we call them trapeziums, so I don't know why the formula sheet's giving us an Americanized word. Okay, so we know ABCD is a trapezoid. So what was our next step in our strategy? We're going to have to find this point Z such that it is perpendicular, such that AZ is perpendicular to DC. So in order to do that, we're probably going to have to find DC first. So we've got the gradient of DC. We've already worked that out, so that's going to be handy. And what we'll do is we'll use that to find out the equation of DC. So I might just underline that to show that I'm moving on to my next step in the plan. So I like to label my equations with the letters that they are associated with. So right now, I'm having a look at DC. So I'm just going to call this YDC. And I just do it in a subscript so that I know which line I'm dealing with, because otherwise your page gets filled up with lots of equations and it's hard to distinguish which one is which. So the formula is Y, I'm going to put it up here, Y minus Y1 equals mx minus x1. That will find you the equation of a line if you have a point and a gradient. So ydc minus, and we're going to just use point D. So let's have point D over here. Minus, so y1 is negative 83.7 equals the gradient of DC is here, 5 over 2 of x DC. I could write a little x DC down there, but I'm just going to keep that as an x. Minus x1, which is 7. Right? So I substituted in point D and the gradient that we found for the D to C. So what we can do from there is it's probably best to get your calculator out at this stage. So let's do it slowly. We're going to do this first. So I'm going to put it as a y now. Y plus 83.7, because a negative times a negative is a positive, equals 5 over 2x. So I'm just expanding these brackets. And then 5 over 2 times negative 7. Honestly, don't worry about doing this in your head. Use a calculator. 5 over 2 times negative 7. That way you won't make mistakes with decimals. You're like, I don't like fractions. So you can make it a decimal, that's fine. Minus 17.5. Okay, so now what we need to do is just move this over. So again, we'll just use our calculator. So we're going to have to minus 83.7 off this side. So we have to do it to the other side as well. So we'll just do answer minus 83.7, and it's negative 101.2. So now we've got the equation of the line. I'm going to go back to calling it YDC. I don't know why I traded out to not calling it DC. That's a bit mean. Equals 5 over 2x minus 101.2. We now have an equation for D to C. We now know how to represent this. So let's go back to what our strategy is. What are we going to do next? So what we're going to have to do next is we're going to have to use the gradient from DC to find out what the gradient from A to Z is, given that it's perpendicular, right? We're going to use this formula here. So let's do that. So we know that MDC times MAZ, right? Because we invented this new point Z here. Maybe I'll show you guys that on the map. Let's just get that on the map so that we can get a better understanding. We've made this point Z here. It's invented so that we can find the height of our trapezoid, right? So what we're doing is we've got this gradient from D to C, and we know that this, we're defining it to be perpendicular. So that's AZ. So the gradient of AZ is going to be perpendicular to DC. And the formula for that is the gradient of DC times the gradient of AZ gets us -1. So we're going to do a little bit of algebraic rearranging. So we know gradient of DC, and it's up here, and it's 5 over 2. So we're going to go 5 over 2 times the gradient of AZ equals -1. From there, we can use the reciprocal. The reciprocal is a really cool idea in maths that's helpful for dealing with fractions. So if I want to get rid of a fraction, all I do is multiply both sides by the reciprocal, which is just the upside down fraction. So I'll times it by 2 over 5 on this side and times it by 2 over 5 on that side, and that'll move it over. So then we get the gradient of AZ equals, what's negative 1 times 2 over 5? That's just negative 2 over 5. So now we know the gradient of AZ. So now we have the gradient of AZ, and we've got point A, we can now find the formula of the line AZ. So we'll call it Y. Maybe I'll split these off because they're sort of different steps. It's probably useful for markers as well, by the way. So YAZ minus, we'll do it using this formula from before. So Y1 is going to be A this time. So we're substituting in point A. Okay, so we'll go minus 15 equals M. What's M? Oh, here it is. Negative 2 over 5 x minus negative 98. Cool. So again, let's just use the calculator so we're less likely to make mistakes. So we've got this here. I'm going to do 2 steps at once. Might be a little confusing. I'm adding 15 to both sides at the same time as expanding this bracket, but I'll do the actual combo separately. So negative 2 over 5x plus 98 times, okay, no, you know what? Don't deal with negatives like this unless you're comfortable. So we can just go negative 2 over 5 times negative, I wonder if this works, times negative 98. Oh yeah, seems happy with it. Yeah, look at that. Negative, negative, negative is going to get us back to a negative. Sweet. You guys probably like a decimal here. Negative 39.2 minus 39.2. And then remember, we're bringing this 15 over as well. Plus 15. We're adding 15 to both sides. Let's do that over here. Plus 15. Oh, wants us to do that again. Negative 24.2. So YAZ equals negative 2 over 5x minus 24.2. Cool. So now what we have is we have an equation for AZ, and we've got an equation for DC. So what we need to do is we need to find out where they intercept, those two lines intercept, and that will tell us where point Z is. So when we want to work out where something intercepts, what we do is we get the two equations and we sort of smush them together. So we've got YDC and we've got YAZ, and we want to find out point Z is at interception. So all I do to find interception is I just set the y's equal to each other, right? So if I say, where will this y be equal to that y? It'll be at the same place where this is equal to that. Then we get rid of the y variable. So we just go 5 over 2x minus 101.2 equals the other side. Negative 2 over 5x minus 24.2. Okay, so what you would do mathematically here is you find out which side's got your bigger x on it and put all the x's onto that side. So this side has the bigger x, so I'm going to change this side to 5 over 2x, and then I'm going to add that to both sides, so it's plus 2 over 5x, and then I'm going to put all these onto that side, so it's going to be negative 24.2 plus 101.2. Okay, from there we're going to have to make these things have a common denominator. So we're going to have to put them both maybe over 10, right? So to make this over 10, I times the top and the bottom by 5. So it's going to be 25 over 10x plus, and then here I'm going to times the top and the bottom by 2. It's going to be 4 over 10x. Here, let's just use a calculator so we're safe. Negative 24.2 plus 101.2, 77. Honestly, if you're lazy and want to use a calculator here as well, you can. You can just do 5 over 2 plus 2 over 5. 29 over 10, 2.9, right? That's pretty easy to do. So, oh, look at that. It makes 29 over 10. So we have 29 over 10x equals 77. And then we just times both sides by the reciprocal again, which is 10 over 29. So it's going to be x equals 77 times 10 over 29. So 77 times 10 over 29. 770 over 29. Oh, it's going to be a yuck number. Okay, we're going to go with the decimal, 26.55. Notice when I use decimals, oh no, actually, they've all just been 1 dp. I'm going to stick them to 2 dp. So these are all 2 dp, they just happen to only have 1 decimal place, right? So it's x is 26.55, and now we just substitute that into whichever equation of these is easier to deal with. I like this one better, to find out our y value. So y is just going to be 5 over 2, substitute in the x. I'm actually going to substitute in the fraction so it's more accurate. 770 over 29. 770 over 29 minus 101.2. So let's just do that on a calculator. We've got the number there, so let's just times that by 5 over 2. And then we'll minus 101.2. Blech, yuck, blech, yuck. They're both despicable. That's disgusting. What is happening in this world? Okay, we're just going to go with that. Negative 34, 2 dp, 0.82. So now we know where point Z is. So let's just write that out. Z equals the point 26.55, comma, negative 34.82. Let's have a look at our diagram just to see that that makes sense. Does that make sense? So Z has it's further to the right than 7. Yeah, 26.55 is further to the right than 7. And it's between numbers 15 and negative 83.7 on y. Yep, that looks pretty logical to me. So I'd say that that's a pretty logical Z value to get out. So now we've got a Z value, we can use that to find the distance between A and Z. So let's do that here. So I like to call it DAZ, and the distance formula is square root, and we just do y2 minus y1 squared plus x2 minus x1 squared. Right, so let's just substitute in those values here. We've got Z down here, and we're also going to use A, and we've got A here. Cool. So I'm going to make Z my y2. I'm going to make Z both of the two values. So we have negative 34.82, negative 34.82 minus, and then we get our AY value, 15 squared. Oh, can I fit it on the page? Yes, I can. 26.55 minus negative 98. Oh, I just got it on there. Honestly, once you get it in this form, don't even bother doing the calculations. It's just going to waste your time, to be honest. If you've got a calculator and you know how to use brackets, it's going to be way faster doing it like this. Negative 34.82 minus 15 squared plus 26.55 minus negative 98. See, notice you don't even have to deal with your negatives. And then close that off. Baboosh. Syntax error. No, what did I do wrong? That means it's coming out as a negative. Oh, I didn't. Okay, sorry. I forgot a bracket here. Notice you have to do a big bracket around everything. So you need to do a big bracket around here on your calculator in order to avoid that syntax error, because your calculator is going to prioritize a square root because that's an exponent in BEDMAS. So that's the second most powerful thing, but brackets are the most powerful. So we're just going to make sure we do the brackets properly. So 134.14. 134.14. So let's have a look at how we need to find our trapezoid. So now we've found H, but we haven't found A and B yet. So we still need to find distance from A to B. So to do that, we'll just have these next to us. So I've got the formula up here, so I'm not going to write it again. I'm going to go 165 minus 15, chuck that in brackets, plus, and then I'm going to go negative 38 minus negative 98 to find the distance from A to B. That's all square root. And if you're really lazy, you can just put it back into there, but it's probably more effort, to be honest. 165 minus 15 squared plus negative 38 minus negative 98 squared. And then close that bracket off. Does that distance seem logical? Let's have a look. I like doing the logic test every now and then. Is that slightly longer than this? Yeah, perfect. Looks about right. Because the picture's to scale. If the picture's to scale, take that, use that to your advantage by all means. Ooh, everything's in meters. So I've actually got to go through and fix all that up. Might do it later on. No, I'll do it now. Meters. Have I done any other distances? No, I haven't actually. Oh, it's fine. Okay, then final distance I need to calculate is DC, right? Because when I'm doing the trapezoid, I need the top and the bottom of it. So I'm going to need DC as well. So distance DC. Let's get these next to us as well. So DC, we're going to do, I'm going to start with this one. 233.8 minus negative 83.7. Oh, shucks, can he fit it on? Yes, he can. 134 minus 7. Oh, heaps of space. Crazy. All square rooted. Cool. Let's go and do that quickly. 233. See how you can be quite systematic about this? This will save you a lot of time and make you less prone to mistakes. The more you train yourself to be a computer on these internals, the better off you are. So it actually just means you got to practice them lots. Like even after you've seen this tutorial video, it's probably even worth just going through doing this whole thing over again to get your head around it. 0.96 meters. Okay, let's do the little logic test because this is drawn to scale. That there, it looks like about half, and that number's about half of that. So it looks good to me. So we've got all the information we need. But let me just use the formula. Area of a trapezoid, I'm just going to draw a little trapezoid down here, equals A plus B over 2 times H. So what's my A? My A is the distance at the top. So that's AB. So that's going to be DAB, which is 161.55. Then B is DC. So distance from D to C is 341.96. And that is all over 2. And then we times it by that height that we found, which is this new one, AZ, which is 134.14. And let's just do that all systematically on a calculator because that's already pretty much in the layout that we want it. So let's do that. 161.55 plus 341.96 all over 2 and then multiply it by 134.14. Whoa, that's humongous. You can't really do like a cool logic test for area because your brain doesn't really comprehend area, two-dimensional, three-dimensional things, as well as it does one-dimensional things like length. 0.42. I'll show you what I do for a logic test. Remember it's area, so it's meters squared. Let's just answer the question properly, and then we'll just have a quick recap. We've given mathematical evidence for each stage of our answer. We've communicated, or have we communicated clearly? Yeah, these labels are clear communication, and we've sort of made sure to point out what we're doing. What we haven't really done is, let's say, area formulas, blah, 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 blah. Calculate the area of the piece of land marked on the diagram. So we just write a little statement. The piece of land marked out on the diagram, oops, that's not the thing, is 33,770.42 meters squared. Let's do, I'm going to show you a little check. So you could probably think of it, if that's 350 meters and the height is 130, let's just do like a logic test. 350 times 130. That's 45,500, which is bigger than that number, but still relatively close and in the same region. So if this was like a rectangle, then that would be a reasonable number, which means, so we know that that's reasonable if it's a rectangle, so that number seems reasonable. It's probably right. So quick recap. What we did was we came up with a strategy first. A lot of people don't know where to start. So having a little visual diagram is really good for having a problem-solving technique. I came up with an alternate solution if this didn't hold. Might be a waste of time, but it's probably good for you guys to think about, just knowing that you can do it that way. We then systematically went through. If you were going for an achieved here, you don't really need to understand this too much. Just realize that some of the distances are going to be relevant. Some of the gradients are going to be relevant. In this one, I don't think midpoints are actually that relevant to the question at all. So you're probably wasting your time if you're finding midpoints. But if you just went through and found 4 distances, and you went through and you found 4 gradients, and what's the other thing we can do? An equation of a line. If you found like an equation of a line, that might be pretty helpful as well. So you just need 2 of the skills. So if you did the distance a few times, got it wrong a couple of times, but got it right once, we can still give you the mark for the distance. So maybe it's good to just go through, find all the distances, all the gradients, and then you're safe. Yeah. And that is about it for the video. If you made it this far, kudos to you. I'll probably put up just pictures of this working as well. But yeah. Cheers. Ka kite anō.